Let's look at section 2.3, linear functions and slope. This review section is a topic that's covered both in intro and intermediate algebra. The slope-intercept form of the equation of a line is written as y equals mx plus b. M is the line slope, b is the y-coordinate of the y-intercept. If 2 points, one with coordinates x1, y1, the other with coordinates x2, y2, are given for a non-vertical line, then the slope m is found by the formula y2 minus y1 over x2 minus x1, which will give the same result as if you calculated y1 minus y2 over x1 minus x2. So it doesn't matter which points' coordinates are labeled as y1, x1. All points that lie on the same horizontal line have the same y-coordinate. All horizontal lines have an equation of the form y equals b, where b is a constant. The slope of a horizontal line is always 0. And let's look at how that happens. y2 minus y1 over x2 minus x1 is how I find the slope. But both y2 and y1 will be b. x2 minus x1 will be something that's not 0. Since these are two different points, they'll have different x-coordinates. Whenever I get 0 over a non-zero number, the result is 0. All points that lie on the same vertical line have the same x-coordinate. Vertical lines have an equation of the form x equals a. A is a constant. The slope of a vertical line is always undefined. M equals y2 minus y1 over x2 minus x1 when we're dealing with a vertical line. Turns into the following. M equals y2 minus y1 over x2 minus x1. But in this special case, when my line is vertical, x2 is going to be the same as x1. And we said, just generically, we'll say that value is a. So I get y2 minus y1 over 0. Division by 0 is always, let me say that again, always undefined. The point-slope form of the equation of a line is written as y minus y1 equals m times x minus x1. x1, y1 is a point on the line, m is the line slope. So let's look at some of the MyMathLab problems. One thing you'll be asked to do is to find the slope of the line that passes through a pair of points. And then state whether the line through the points rises, falls, is horizontal, or is vertical. Also, you'll have the option to determine if the slope is undefined, if that should wind up being the case. So we're using our difference quotient to find the slope. We subtract the y's in the numerator and the x's in the denominator. And we make sure whatever y came first in the subtraction, its x is first in the subtraction in the denominator. And so we wind up with a slope of 3 over negative 11. And notice that I want to make sure my y's are in the difference of y is what is in the numerator, and the difference of the x's is what is in the denominator. And that if a y came first in the numerator, the corresponding x comes first in the denominator. When the slope of a line is negative, the line falls as x increases from left to right. So you would put this slope, you would select A and put the value of the slope in the box, and then you would be saying that the line falls. That would be an option on the second part of the problem. Similar problem, we want to find the slope between these 2 points that lie on the same line. We subtract the y's in the numerator, the x's in the denominator, making sure each y is over its x. We see that the points have the same y, so the slope is 0, which means the line is horizontal. So I'm going to put 0 in the box, and then for the second part of the answer, I'm going to be indicating that the line is horizontal. All right, again, I have 2 points that lie on the same line, and I want to find the slope. So I'm going to find the difference quotient. I can set up a horizontal fraction bar and the 2 subtraction signs first, then make sure each y is directly over its x, and subtract. A double negative is a positive, so I actually in the denominator have -9 plus 7, which is -2. So the slope here comes out to be 1. And 1 is the value that I give as the answer, selecting A, where I'm giving a slope value. When slope is positive, the line rises as x increases from left to right. So I would be indicating that for the second part of the question. Here I'm again given 2 points that lie on a line. I want to find their slope. I set up the difference quotient. I notice that these 2 points have the same x-coordinates. That means I'm going to get a non-zero number in the numerator and 0 in the denominator, which is always undefined. So I choose part B for the first part of the answer, and then for the second part of the answer, I'll choose the answer or fill in the answer that indicates what it means when my slope is undefined. So the line is vertical. When the point-slope form of the line's equation satisfying the given, we want to write the point-slope form of this line's equation. The slope of the line is 2, and it passes through the point 6, 7. So we want to first write the point-slope form of the line's equation. So y minus y1 equals m times x minus x1. And we replace the y1 with 7, the y-coordinate of this point. We replace m with 2, the value of the slope of the line, and the x1 with 6. So this is the point-slope form of the line equation, and that's what I would be typing into the box for the first part of the question. This is my answer to the question's first part. Then I'm asked to use this to write the slope-intercept form of the line equation. So I want to solve for y. I distribute, getting 2x minus 12 on the right, add 7 to both sides, and I get y equals 2x minus 5. And this will be the answer that you'll put in for the second part of the question. So we want to use the fact that our line passes through these 2 points to find its point-slope equation form. So we set up our difference equation. To get started, we need the slope. So we do our difference quotient, making sure each y is aligned over its x. The y is in the numerator, the x is in the denominator. The double negatives become positive. I get 10 over 5, which is 2. So the point slope equation template is y minus y1 equals m times x minus x1. y1, I can use either point. I'm going to use a point that has the positive coordinates. You could use the other point. You're going to get the same equation in the end. So y minus 5 equals 2 times x minus 2. So the 2 in the parenthesis comes from the x coordinate of 2. The 2 in front of the parenthesis comes from the slope. The MyMathLab will also accept y minus negative 3 equals 2 times x minus negative 5. Now I'm going to simplify this in order to find the slope-intercept form of the equation. So I distribute and then add 5 to both sides to get y equals 2x plus 1. So that's the slope-intercept form of my line equation. All right, I want to use the given conditions to write the point slope-intercept form of the line equation. So I'm going to write both forms of the line equation. So remember that the x-coordinate, the x-intercept is the point whose y-coordinate is 0. So if the x-intercept is 2, we're going to write it as the point 2, 0. And we're going to do our difference equation that gives our difference quotient that gives us slope. So we're going to look at the difference of the y coordinates in the numerator and the difference of the x coordinates in the denominator, making sure each y is directly above its x. And when we do those two differences, we get 2 as the difference in y, change in y, and 3 as the change in x. So 2/3 is our slope. So I'm going to use the x-intercept, the point 2, 0, as my x1, y1, and I'm going to use the point slope form of the equation. Y minus y1 is y minus 0, m is 2/3 times x minus x1, which is x minus 2. And I'm going to simplify that. Y minus 0 is just y. 2/3 times x minus 2 is 2/3 x minus 4/3. And 2/3 times 2 is the same as 2/3 times 2 over 1. I multiply the numerators to get 4. I multiply the denominators to get 3. And that's where technically I'm doing negative 2/3 times 2, which is negative 2/3 times 2 over 1, which is negative 4 over 3. So that's where that negative 4 over 3 is coming from. All right, now I want to, so this is my slope-intercept form of my line equation. And that's the second part of the problem. You'll be putting in that equation for the answer if this were your MyMathLab problem. All right, now I want to do the graphing exercise that gives me a line equation. Here I'm getting this in the form ax plus by plus c equals 0, and I'm asked to graph it using the intercept. So I'm going to start with the y-intercept, which is found by setting x equal to 0 and solving for y. So 5 times 0 plus 2y plus 10 equals 0 is the same as 2y plus 10 equals 0. I subtract 10 from both sides of the equation. I now have 2y equal negative 10. I divide both sides of the equation by 2, and I get y equals negative 5. Now I'm going to find the x-intercept by letting y equal to 0 and solving for x. So I get 5x plus 2 times 0 plus 10 equals 0. That's the same as 5x plus 10 equals 0, since 2 times 0 is simply 0. So I'm solving 5x plus 10 equals 0. I subtract 10 from both sides, and I get 5x equal negative 10. I divide both sides of the equation by 5, and I get x equals negative 2. So I have 2 points. I have the point negative 0, negative 5, which lies on the y-axis, and the point negative 2, 0, which lies on the x-axis. And then I'm going to connect those 2 points by drawing the line through those 2 points. So you're going to use your line tool, and that will allow you to draw the line that passes through these 2 points. I'm not actually in MyMathLab, so I'm in the Microsoft Word, so I'm going to use shapes to draw this line. And I'm going to just make this a little thicker. And when you're drawing a line on a handwritten test, you want to extend the line outside of the graph, as I've done here. And use a straight edge so your line is straight. You can use another pencil, or if you haven't turned in your name card to borrow a calculator, you can use your name card. Alright, so let's go to the last problem, where you also want to graph a line that's given to you in slope-intercept form. So you're asked first to say what the slope is. The slope is the number multiplied by x. So that slope is negative 1 over 8, the coefficient of x, when y is isolated on one side of the equation. The y-intercept is the constant in the problem, and so that constant is 4. Now notice, in order to extract this information, you have to have y isolated on one side of the equation, and the other side needs to be simplified. And so you'll be putting the 4 in the box for the second part of this problem. The third part of the problem would be to plot the y-intercept. So you actually want to graph the line. So your first step in graphing is to plot the y-intercept on the y-axis. And so from the origin, you're going to move 4 units up, since your y-intercept is the positive number 4. If the y-intercept were 0, the y-intercept would be at the origin. If the y-intercept was negative, from the origin, you would move however many units indicated down. Then we're going to use the slope to move from the y-intercept to a second point on the line. Now this line has a slope of negative 1/8, which you can think of as negative 1 over 8 or positive 1 over negative 8. If you think of it as negative 1 over 8, from the y-intercept you move 1 unit down and then 8 units right. Or if you think of it as 1 over negative 8, from the y-intercept you move 1 unit up and then 8 units left to get to your second point on the line. Let's look at both of those movements. So here I've moved 1 unit down and 8 units right. The point to the left came from moving 1 unit up and then 8 units left. Both points lie on the line. You only need to do one of those movements to get a second point. I'm just showing you that you could use either set of movements. One set of movements up and left gives you the leftmost point. The other set of movements to move 1 unit down and 8 units right gives you the second point on the line. All right, and this is how you would graph the line using the slope and the y-intercept.